This is the first in a series of videos about my return to ham radio after about 50 years. I was active as a kid in the late 1950s. Then I let my license expire, and just recently I got my general class license. I love building homebrew equipment. It was a passion for me back then, and it is now. This first video is about getting started with software-defined radio receiver. Later videos will cover antennas and a transmitter. Here's a view of my receiver setup. On the left is a ham-it-up converter from Newelec feeding into an RTL SDR dongle, which is one of those little cheapo gizmos folks are using along with computer programs to listen to shortwave these days. On the right is a shot of my computer screen running the GQRX SDR program. For an antenna at this point, all I have is a few feet of hookup wire draped over a nearby chair. And this is entirely indoors. I'm not allowed to have external antennas where I live. When I first fired this up a few days ago, all I heard was static, RFI, radio frequency interference. Well, that was kind of discouraging, but after all, what would you expect? Who's going to be surprised? There are YouTube videos of people using much the same equipment and getting good reception, receiving lots of signals. So I rolled up my sleeves to see what I could figure out. This video will cover several steps I've taken to improve things. First, I noticed that when I initially tried listening, the high-frequency bands were dead. At my location, signals around 7 to 8 megahertz start showing up in the evening. I recently picked up a Texan PL600 all-band radio. It's an excellent radio, which serves for me as a kind of a reference point for whether there's anything available to hear. When evening came, I soon found several strong AM shortwave stations above 40 meters, usually with religious programming. Some of these came in okay with my dongle and SDR setup. One of the first ones I heard was coming from the Netherlands. This was exciting. At least it established that my little apartment isn't a Faraday cage. Little whispers of RF were somehow finding their way inside. But what to do about all the wicked, fierce static? Maybe I was surrounded by neighbors with plasma TVs. Oh no. Two things helped to improve the signal and lessen the noise. The first was to slightly improve my antenna. I made it a little longer and ran it out to a small balcony attached to my apartment unit. It's still a very short piece of random length wire, but it did improve signals a bit. I also added a balun from Newelec, actually connected as an unun, to the front of the ham-it-up converter. Second, it didn't take long to discover how much RFI noise was coming from my computer and from various AC adapters around my place. There's a YouTube video showing good reception with the ham-it-up converter and RTL dongle. It was made outdoors with a decent wire antenna and with the SDR software on a laptop. I'm guessing the person's laptop was running on battery power. Unfortunately, I don't have a laptop. I run the GQRX SDR software on my desktop machine. So that's one noise source I can't easily eliminate. The portions of my setup with RF electronics are the ham-it-up converter and the RTL dongle. Currently, these are completely unshielded. I tried some experiments with USB cable modifications and was able to lower the noise somewhat. USB has 4 wires, 2 for signal and 2 for power and ground. I put together a jig using old USB cables that routed the signal and power separately. The female connector that the RTL dongle plugs into has its signal and ground wires connected to the plug going to the computer as usual, but instead of getting plus 5 volts from the computer, that wire goes to the yellow colored cable in the picture being shown. A separate cable supplying plus 5 to the ham-it-up converter is also connected to the yellow cable. With this contraption plugged in, I was able to plug the yellow power cable into either a battery, like the black cell phone charger in the picture, or into an AC adapter, like the white one next to the battery. This did make a difference. The noise floor was about 6 to 7 dB lower with battery power than when using the AC adapter. So that was encouraging. There are reports on the internet of using decoupling capacitors between the power and ground on USB cables. Typically, a couple capacitors are used, 10 microfarad tantalum and a 0.01 ceramic. Also, putting ferrite cores on or around the cables and even shaping the cables themselves into special accordion-like shapes. I read about one person who did that and reported improvement. Improvements are also possible by putting the dongle and ham-it-up converter into a shielded container. As for the AC adapter and power supply source of noise, I'm looking at options. Having a battery-powered receiver sounds attractive. Going the laptop route is one way, but I'd rather avoid that. Popular microcomputers like the BeagleBone Black and Raspberry Pi can run on batteries, but they don't appear to have the computer horsepower to run SDR software like GQRX. My future plans include building a magnetic loop antenna with copper tubing. This is a resonant antenna with a variable capacitor, and it has a very high Q. Some folks report using these as indoor antennas with good results. I noticed the AC adapter noise problem affected my Texan all-band radio as well. That radio has NiCad batteries, and it also comes with an external adapter charger. I was using it running on batteries, but one time I had it tuned to WWV at 5 megahertz, and while it was receiving WWV, I tried plugging in the adapter, and sure enough, the noise picked up quite a bit. I'm going to play a short sound clip here where you'll hear WWV. It's pretty faint, but 2 times there will be a marked increase in noise, and that's when I plugged in the adapter for just a second or two. And finally, I'm going to leave you with WRMI at 7570 kilohertz coming from the Netherlands, being received on both radios. The sound is going to fade back and forth from one to the other. Even though I can't guarantee that the audio is completely in sync, both recordings of video and audio were made at the same time. 73 from San Diego, California.